The background of the studies are dengue is a viral infection transmitted by mosquitoes, and it is common in tropical and subtropical regions. Most infected individuals show no symptoms. Common symptoms are high fever, headaches, body aches, nausea, and skin rash. Most patients recover within 1 to 2 weeks, and severe dengue may require hospital treatment according to WHO on 2025. In Malaysia, approximately 555,000 reported cases were recorded from the year 2000 until 2023. The total deaths recorded are 2,076 cases. This study focuses on the relationship between number of reported dengue cases and the total deaths caused by dengue in Malaysia. The variables in the study are manipulated variable, the number of reported dengue cases. Respondent variable are the total dengue-related cases. The positive correlation observed is the increase in reported cases to increase in total deaths. This study emphasizes the importance of early detection, effective motor control, and prompt medical treatment. The objectives of the studies are to determine the relationship between the number of reported cases and total deaths caused by dengue in Malaysia. Secondly, it is to obtain the types of graphs that are suitable for the data. Thirdly, to find the values of mean, standard deviation, and encodal range. Fourth, to determine the correlation and regression of data. As for the significance of data of study, data is easily accessible from the WHO website. Therefore, it saves time and cost since it doesn't need primary data collection. The data recorded are reliability and is high. This is because it is collected by expert researchers. It is also suitable for statistical analysis and comparison. Secondary data is cheaper and faster to obtain. Thank you, that's all from me.
Now, I will explain the limitation of our study. First, we had no opportunity to directly question the data providers, so we relied on only existing sources. Secondly, the accuracy of the data could not be verified through interviews or surveys. Third, some of the data may not fully match our study objective. Fourth, much of the data was sourced from researchers in other countries, which may not fully reflect our local context. Lastly, the differences in research proposed may affect how the data is interpreted.
Hello everyone, my name is Daniel and I will discuss with you guys about Chapter 2 Methodology. For the methodology, I will start with the sample. The sample used in this study consists of annual dengue data in Malaysia from the year 2011 until 2021. There are 7 observations in total, where each year represents 1 year, 1 observation. This sample is suitable to describe the pattern of dengue case and deaths over time. Next is the data collection method. This study used secondary data, which means the data was already collected by official organizations. The data was obtained from published dengue statistics by government agencies. Using secondary data is appropriate because it is reliable, accurate, and officially recorded. After that, the sampling technique were used in this study to purposive sampling. This is because only relevant and complete data was selected based on the objective of the study. The study focused only on dengue data in Malaysia, so purposive sampling is suitable. Next is variables. There are 2 variables involved in these studies, which is the independent variable is the number of dengue case, while the dependent variable is the number of dengue deaths. Both variables are quantitative because they involve numerical and countable data. Next is measurement scale. Both variables are measured using the ratio scale. This is because the data has a true zero value and equal intervals. The ratio scale allows statistical calculation such as mean, median, and standard deviation. Now, to conclude our chapter 2, this study will use a secondary annual data and descriptive statistical methods. Group data, graphical techniques, and numerical analysis were applied according to the our STA108 syllabus. Now we move on into 2.3 for graphical techniques. In STA108, graphical techniques are used to present data visually so that patterns and distributions can be understood more easily. These techniques help to summarize large sets of data and allow comparisons to be made quickly. Graphical methods are especially useful for identifying the shape of the distribution, central tendency, and spread of the data. Common graphical techniques used in STA108 include histograms, frequency, polygons, ogive, bar charts, pie charts, stem and leaf plots, and box plots. The choice of graph depends on the type of data, whether it is qualitative or quantitative, and whether the data is grouped or ungrouped. In our study, we used the histogram graph and ogive graph because our data is the secondary data, which is a quantitative data, and the data is also a group data. Next, I'm gonna discuss with you guys about what is histogram. A histogram is used for group quantitative data where the horizontal axis shows the class intervals and the vertical axis shows the frequency. It helps to identify the shape of the data distribution, such as whether the data is skew or symmetric. Next is ogive. An ogive, also known as a cumulative frequency curve, shows the cumulative frequency against the upper class boundaries. The ogive is useful for determining the median, first quartile, and third quartile.
Next, I will explain the numerical techniques used in our studies. First, the mean. The mean is the average of the data. We calculate it by adding all the values and dividing it by the number of observations. It can be used for both group and ungrouped data. Next is the median. The median is the middle value when the data is arranged in ascending order. It divides the data into two equal parts, where 50% of the value are below the median and the 50% are above it. Lastly is the mode. The mode is the value of classes interval that occurs most frequently in the data. Like the mean, it can be calculated for both group and ungrouped data.
And next, for chapter 3, I'm going to explain about the result and data interpretation. And this is the data that we had collected, which is the number of cases and the total death of each year from 2000 until 2004. All the data were collected by me from two websites, which is Kementerian Kesehatan Malaysia and iDengue, with a total death of 1,300, 4,067 cases, and 208,033 deaths. For the figure above, this is the histogram for the number of dengue cases reported. Based on the histogram, this data is positive as it is skewed to the left. With the highest cases ever reported were around 133,000 cases and the lowest were around 500 per year. The number of cases can be seen to be frequent at around 40,000 and above. The histogram above shows the data of the number of deaths caused by dengue. Based on the histogram, the data is positive and skewed to the left. The highest death is around 3,040 deaths and the lowest is around 20 deaths per year. The number of deaths can be seen to be frequent around 100 to 125. The figure shows the box plot for the number of dengue cases reported. The median in this data is approximately 46,171. The lower quartile is around 32,767. The upper quartile is around 90,304. The minimum and the maximum values of 700, 1,030 and 130,101. The distribution appears to be positively skewed. The figure above shows the box plot for the number of deaths caused by dengue. The median in this data approximately 100. The lower quartile is around 72 and the upper quartile is around 144. The maximum and minimum values are 336 and 20. The distribution appears to be positively skewed. And this is the descriptive. For number of reported cases is 60986.84. The standard deviation is 38488.81 and the median is 41671. However, for the death caused by dengue, the mean is 115.72. The standard deviation is 71.646 and the median is 100.
I will explain about 3.1 correlation and regression. The first one is 3.3.1 scatter plot. This scatter plot suggests a positive correlation between the number of reported dengue cases and total death caused by dengue in Malaysia from the year 2000 to 2024. Next, I will explain about 3.3.2 correlation. The value of R is 0.745, suggests a moderate correlation between the number of reported dengue cases and total death caused by dengue from the year 2000 to 2024. That is, the higher number of reported cases, the higher the total death due to the disease. The third one is regression. From the table above, coefficient of determination R is 0.55, means that 55.5% of the variety of total death can be explained by the number of reported cases. Secondly, the remaining 44.5% is unexplained variability of total death. Next, the regression equation is y equal to 31.116 plus 0.001x, and the value of B1 equal to 0.001 means that for every increase in the number of reported dengue cases, the total death will increase 0.001. Fourthly is 3.3.4 fitting a straight line. From the graph,
that we can see, the interpret the slope is if the number of reported cases is increased by 1 rate, the total that predict will increase by 0.001. And the secondly is interpret the intercept is if the number of reported class is 0, then the total that predict is 31.116. Lastly, for conclusion, the study conclude the dengue cases and the death in Malaysia have a moderate positive correlation, that is R is equal to 0.55, and the data set has a mean 115.72, a standard deviation of 71.65, and interquartile range of 72, and is the best represent using a histogram. Then the regression equation is y equal to 31.116 plus 0.001x indicate that each additional reported case is associated with a predicted increase of 0.001 in the number of deaths. That's all from us. Thank you.